Q3655. A precaution for the operation of an engine equipped with a constant speed propeller is to A. Avoid high RPM settings with high manifold pressure. B. Avoid high manifold pressure settings with low RPM. C. Always use a rich mixture with high RPM settings. The correct answer is B. Aircraft equipped with a constant speed propeller have separate controls for engine power output and propeller blade pitch angle. The throttle control is responsible for adjusting the engine power output, which is indicated on the manifold pressure gauge. The propeller control, on the other hand, is used to change the pitch angle of the propeller blades, thereby governing the RPM, revolutions per minute, of the propeller as indicated on the tachometer. It's important to note that for a specific RPM setting, there is a maximum manifold pressure that should not be exceeded. Carrying an excessive amount of manifold pressure for a given RPM can potentially surpass the maximum allowable pressure within the engine cylinders, leading to excessive strain on the engine components. Therefore, it is crucial for pilots to operate within the recommended manifold pressure limits to ensure the engine operates safely and efficiently. 3207. In what flight condition are torque effects more pronounced in a single-engine airplane? A. Low airspeed, high power, high angle of attack. B. Low airspeed, low power, low angle of attack. C. High airspeed, high power, high angle of attack. The correct answer is A. In a single-engine airplane, torque effects are more pronounced in the flight condition of low airspeed, high power, and high angle of attack. These factors contribute to an increased asymmetrical thrust produced by the engine, resulting in a greater left-turning tendency. Pilots should be aware of this effect and apply appropriate rudder input to counteract the yaw and maintain coordinated flight. 3208. The left-turning tendency of an airplane caused by P-factor is the result of the A. Clockwise rotation of the engine and the propeller turning the airplane counterclockwise. B. Propeller blade descending on the right, producing more thrust than the ascending blade on the left. C. Gyroscopic forces applied to the rotating propeller blades acting 900 in advance of the point the force was applied. The correct answer is B. The left-turning tendency of an airplane caused by P-factor is the result of the propeller blade descending on the right side producing more thrust than the ascending blade on the left side. This imbalance in thrust creates a yawing moment that tends to turn the airplane to the left. P-factor is most pronounced at high angles of attack, such as during climb or at low airspeeds. 3209. When does P-factor cause the airplane to yaw to the left? A. When at low angles of attack. B. When at high angles of attack. C. When at high airspeeds. The correct answer is B. P-factor causes the airplane to yaw to the left when at high angles of attack. P-factor is a phenomenon that occurs when the aircraft is flying at high angles of attack, such as during climb or slow flight. It is caused by the unequal distribution of thrust produced by the propeller as a result of the varying angle of attack of the descending and ascending propeller blades. 3658. During the pre-flight inspection, who is responsible for determining the aircraft is safe for flight? A. The pilot in command. B. The owner or operator. C. The certificated mechanic who performed the annual inspection. The correct answer is A. During the pre-flight inspection, the pilot in command is responsible for determining whether the aircraft is safe for flight. The pilot in command has the ultimate authority and responsibility for the safety of the flight. While other individuals, such as the owner or operator and certificated mechanics, may have roles in ensuring the airworthiness of the aircraft, the pilot in command has the final decision-making authority in determining the aircraft's readiness for flight.